I asked one person how they're doing. They're saying, "Oh, they're pretty good." I said, "Really?" And they were like, "Yeah, pretty good. You guys doing all right?" You know, it's supposed to hit almost 70 by Saturday again. Crazy. I mean, it was 20s, freezing, crazy. All right, Nehemiah, are you with me?
Yeah.
Okay, let's put that away. On page 103. Anybody going in the medical field? Maybe. Okay, so you guys, well, I don't know if you would have to do this or if the doctor would. Maybe you might have to check. So here's the problem. A doctor orders 250 milligrams of Rocephin. Is that how you say it? Do you guys know? Rocephin? Nobody knows. Rocephin. I think it's Rocephin, now that I say that out loud. Okay. To be taken by a 19.8 pound infant every 8 hours. The medication label shows that 75 to 150 milligrams per kilogram per day is the appropriate dosage range. Is this doctor's order within the desired range? Well, first of all, the fact that you're even questioning it, I mean, this is a math problem, so of course we're going to question it. But hopefully, you know, if the doctor has that figured out and tells you, I don't question that, you know. If they tell you, that's what I do. But this is a math problem, and we are checking to see if it is correct. Well, how about us? Thanks for gracing us with your presence. I did. We already talked about why, too. All right, so a doctor orders 250 milligrams of Rocephin to be taken by a 19.8 pound infant every 8 hours. The medication label shows 75 to 150 milligrams per kilogram per day is the appropriate dosage range. Is this doctor's order within the desired range? And they give us all kind of equivalent conversions over here. Okay? 1 inch, 2.54 centimeters. Do you think we're going to use that one in this problem? Anything with length about centimeters or inches in this problem? No. A mile and kilometers? No. A pound and kilograms? Maybe. And a gallon and 3.785 liters? No. So, how are we going to approach this problem? All right. Put it away. In the backpack. Away. How are we going to approach this problem? Very carefully. Yes, yes. How are we going to approach this problem? What do you think? What would you do? What could we write down? 250 milligrams of this medicine to be taken by a 19.8 pound infant every 8 hours. Huh? What about the weight? Is that what you're saying? Well, because we need to see if that is the appropriate dosage. Well, we have an equivalent conversion here. Yeah, we're doing equivalent conversions, unit conversions. So, you have a theory, a thought? Yes? Okay. Okay. Then I multiply that answer by 3. 8 times 3, 24 hours in a day, and that's how it is per day. Okay. All right, does everybody hear what he said? And he's right. So 250 milligrams to be taken every 8 hours. So let's start with that. 250 milligrams per, and that's usually your division bar there, 8 hours. Okay? Now, take a look at the medication label. They are showing 75 to 150 milligrams per kilogram per day. Well, we only have it in 8 hours right now. So, yes, we need to take it into days. So, what is an equivalent amount that I can put here, an equivalent ratio that deals with hours and days? Well, we know there are 24 hours in a day, right? So this hours is going to cancel out, and I would need to then take 250 times 24. This is where the calculators come in handy, and divide that by 8. So 250 times 24 divided by 8. Oh. And yes, 24 divided by 8, we know that's 3. So it's 250 basically times 3, which is 750 milligrams per day. So then they have milligrams per day. But we have to take milligrams per kilogram per day. Well, what do we know about this baby? Right. So if we have 750 milligrams per day, 750 milligrams per day, and we know that, let's see, milligrams per kilogram. So we would need to take 19.8. 1 pound is going to be, let me put this up here. 1 pound is 0.454 kilograms. Okay? And our baby is 18 pounds. So I think 18.9. So I think we take this times 18.9 pounds, because that's the weight of the baby, times 1 pound is equivalent to 0.454 kilograms, right? So then the pounds will cancel out, and I have 750 milligrams per kilogram per day. Is that right, maybe? So somebody take 750 times 18.9 times 0.434. Is that going to work? Please say yes. Try the calculator. Try the calculators. That is not it. I should have stopped at the 750. All right, let's back it up. Back it up. I told you this was not my forte. So we're going back to here. The baby should get 750 milligrams per day. Okay? We need to see if that is within this range. Okay? So we're going to do the low set, or the low end of the range first. And we're going to take 75 milligrams per kilogram per day times the baby, 1 pound and 0.454. Yeah. Right? Per day.
Per kilogram of baby weight. No? It's just saying milligram. Either or dosage, either or unit.
What's your question?
It's saying 75 to 150 milligrams or kilograms per day.
Uh-huh.
What's the kilograms?
The kilograms is that 1 pound is 0.454 kilograms. So we need to figure the baby's weight in there to see if we can do this. So it's 75 milligrams per kilogram per day times, we have a 19.8 pound baby. I'm going to put that out front. 19.8 pound baby times that times 1 pound is 0.454 kilograms. So the pounds are going to cancel out. The kilogram is going to cancel out here. So can someone take 19.8 times 75 times 0.454 and tell me what we get? 19.8 times 75 times 0.454. And that is going to be milligrams per day. So that's on the low end of the dosage because we started with this 75. So that's good. I mean, that's the low end, and we're looking at 750. But we need to make sure we're not going higher than that. So now we're going to do the same thing with 150, which is the upper end of the dosage. Okay, so it has to be somewhere in the middle. So that is same baby. So that is 19.8 pound baby times, this time we're checking for 150 milligrams per kilogram in a day times, and it's still, the poundage is the same, 0.454 over 1 pound. So the pounds will cancel out. The kilograms on here cancel out. And what do we get for an answer here? 19.8 times 150 times 0.454. Who's got that? What do you got?
So it's just same thing, but so like 75 to 150, right?
Yeah. 1,348.38 milligrams per day. So this is the upper end. So if this baby, he was given 250 milligrams, which is going to be 750 milligrams a day, is that within the allowable dose of 674 to 1,348? Is that within that window? Does 750 come between 674 and 1,348? Yes. So the answer is yes, this is an appropriate dosage. Okay. Does that make some sense? So we had to find the appropriate dosage for the day, and then we had to check it with the low end and the upper end. Okay? All right. questions about that? All right, let's go to the next one. Whew. Okay. Agriculture. So we're going to be farmers. You own an empty 1 acre lot. Okay. They are telling us these are some equivalents. 640 acres is equal to 1 mile squared. So an acre is a measure of area. Okay. And 1 mile is 5,280 feet. So this, in particular, is an individual length, and this is talking about area. That is very important to recall. Okay? So, if 1 inch of rain falls over your 1 acre lot, so 1 inch falls over your 1 acre lot, how many cubic inches of water fell on your lot? Ooh. So cubic inches, that's talking about volume. Cubic inches of water fell on your lot. All right, so let's take a look at our conversions over here at the far right. 1 inch to centimeters, I don't think we're using that. 1 mile into kilometers, I don't think we're using that. I don't think we're using any of these. 1 pound. Okay, so it's probably maybe just these. So an inch of rain fell on your 1 acre lot. 1 acre lot. How many cubic inches of water fell on your lot? Okay. Anybody have any ideas of how to start this? Demarion, any ideas on how to start this? 1 inch of rain fell over your 1 acre lot. How many cubic inches of water fell on your lot? Cubic inches. Inches. Are you guys talking math over there? Okay. One acre lot. 1 mile. One inch of rain fell over your 1 acre lot. So let's say you had an acre, and that was your 1 acre. 1 inch of rain is going to fall all over that. All right, I'm going to have to use my cheat sheet. Okay. So we're starting with 1 inch of rain. This always makes sense after I look at it. So 1 inch of rain. Okay. And we are going to multiply that by an equivalent ratio. All right. So we are going to want inches to be let's see, I was going to say on the bottom. All right, we'll see if this works. We need some type of equivalent amount. Since we are talking about an acre, which is area, Okay, we're dealing with area here. We are going to have how many cubic inches? Okay, so we want cubic inches. We want inches to the third power. Maybe that's why, because we're not canceling these out. What's an equivalent amount to inches that we know might lead to, in this case, acres? Well, it would be that 12 inches are equivalent to 1 foot. Okay? That's an equivalent conversion. The problem is we need to talk about this in terms of area. So we are going to square this whole thing. Okay? And I'm going to rewrite what that is squared right next to it. Okay? So 1 foot squared. If you square 1, you're still going to get 1 foot squared, right? If I have 12 inches squared, what is 12 squared? That would be 144. And I did it wrong again. Gosh. Okay, so the equivalent is not incorrect, but I have it on the wrong side because we want inches to the third power. So I'm going to back this up. I thought I had it. We want 12 inches here equivalent to 1 foot. And then we are squaring it because we are talking about area. That gives me 144 inches squared compared to 1 foot squared. Okay? So what I am doing, I'm writing it like this, and then I'm squaring it right next to it. Okay? So then we're going to multiply that because we know this was for 1 acre. So then up here, I'm going to say 1 foot squared, and 1 foot squared, no, sorry. We are putting 5,280 feet squared is equivalent to 1 mile squared. Okay, so on your calculator, someone please take 5,280 feet squared and tell me what you get. It's going to be a large number. Do you have it?
Yeah.
Okay.
You ready?
Yep.
So it's just 5,280 squared, right?
Yep.
27,878,400.
Okay. So 27,878,400 feet squared divided by 1 mile squared is still going to be 1 mile squared because 1 squared is 1. Okay. All right. That takes it to a mile. And then we also know, let's see, 1 inch. Do I have to do anything with acres here? Yes, I do. Times, I'm going to say 1 mile squared is equivalent to 640 acres, which is also squared. There's not enough room in this. No, it's not squared. 1 mile squared is 640 acres, so remove the 2 just at the end. Okay, and 1 mile squared is just 1. So I am crossing out these because I have found what they are squared right next to them. So here's what we need to do. We need to take 1 times 144 times 27,878,400 and divide it by 640. Because the miles will cancel out. The feet squared is going to cancel out. And we will have inches to the 3rd power, which is volume, over acre. So is anyone taking 144 times the 27 million number and dividing it by 640? It's going to be a large number. Everybody should be doing it because this is what you will have to do. Well, probably not for your big project, but you have to know how to do it. Arturo, that means you too. Huh? It's going to be another project. Yes. All right. What do you have? 640 inches to the 3rd power on our 1 acre. Ugh. Okay. Yikes. All right. Could you do that on your own? Here's what we need to remember. We had 1 inch of rain, so that's what we started with. Over our acre lot. Acres went to miles. So each time we needed to multiply by an equivalent amount going from inches to feet, feet to miles, and then miles to acres. And the thing we needed to remember, since it was talking about cubic inches, is that I didn't want to put the inches on the bottom to cancel them out. I needed to find inches squared on the top. So I ended up with inches to the 3rd power, which is volume. Okay? All right. Let's see if we can do this next one. Yeah, this one always runs out of time. So how many cubic feet of water fell on our lot? So we start with the answer we just had, 6,272,640 inches cubed. And we need to figure out how many cubic feet. So we are changing this into feet. So I need to multiply this by an equivalent ratio, which deals with inches and feet. Okay? So I am going to say that 12 inches is equivalent to 1 foot, right? Yes? You know this, right? Just say yes. Yes, you know this. 12 inches is 1 foot. Yes, Jaden? Good. Now, we need cubic feet. So that means I am going to have to take this all to the 3rd power. Well, if I take that to the 3rd power, I also have to take my 12 inches to the 3rd power. Okay, well, 1 to the 3rd power is still going to be 1, and it's feet to the 3rd power, but 12 to the 3rd power means 12 times 12 times 12. So can someone take 12 to the 3rd power and tell me what that is? 1720. Thank you. And that is 1,728 inches cubed. So this here in these brackets is equivalent to this, but we still are multiplying. So inches cubed is in my numerator. That's what I started with. That's going to cancel out with inches cubed on the bottom. So to get my answer, you need to take that 6 million number and divide it by 1,728. So 6,272,640 divided by 1,728 gives you anyone? Yes. 3,630. And how is this going to be labeled? Cubic feet, which is the same as feet to the third power, or cubic feet. Cubic feet. Yay! That one was a whole lot easier. All right. Did you follow that one? Yeah, that was a whole lot easier. Okay. Now, 1 cubic foot weighs 62 pounds. 1 cubic foot weighs 62 pounds. Well, what's going to be the weight of this 3,630 cubic feet? What would I need to do there? Think about it. 1 cubic foot is 62 pounds. We have 3,600, oh, I wanted to circle that, 3,630 feet. So what do I need to do with that? Come on, people. Put on your thinking caps. Meow. Gentlemen, 1 cubic foot of water is 62 pounds. I don't have 1, I have 3,630. So what should I do? Yes, multiply by 62 pounds, right? And if you're wondering, how did you get that? Well, you just multiply. You could take, oh gosh, let's see, where's the equivalent? Pounds, feet. What do we get for an answer there? 3,630 times 62 is 225,060 pounds. That's how much your water's going to weigh. Pounds, pounds, pounds. Oh, you could do it like this, 1 cubic foot. So this would be 1 foot cubed. And so these would cancel out if you want to do it that way. So that's how much the water is on your acre of land. And finally, it says, if the weight of 1 gallon of water is approximately 8.3 pounds, how many gallons of water fell on your lot? So 1 gallon is 8.3 pounds, but we have 225,060 pounds. How would I figure out how many gallons of water? Start with that number, 225,060. That's pounds of water. And you can essentially divide it by 8.3 pounds because 1 gallon weighs that much. So take this number, divide it by this, and tell me what you get. This is the audience participation part. 225,060 divided by 8.3. What do we get? 27,000. Is anybody checking me? 115.6 gallons of water. Did anybody get that?
Yes.
Yeah? Did anybody calculate it? You got that? Thank you. So again, we had this many pounds of water. 1 gallon of water weighs 8.3 pounds. So there it is. Whew. All right. We got one more. Let's see. When does the clock end? 54. All right. We're going to the end. We're going to go until the bell rings. Okay. All right. Light travels. I know you're excited about that, aren't you? Light travels. Let's see if we can just do the first one. 186,282 miles per second. Really fast. How many miles will light travel in 1 year? All right. In 1 year. So if light travels 186,282 miles in 1 second, basically we're taking seconds to a year. So we have to find equivalent amounts, okay? So start with, what do we know about seconds and the next higher level of time? It would be seconds and minutes. So I'm going to put seconds up on top, minutes on the bottom. How many seconds are in how many minutes? What's the equivalent ratio? 60 seconds are in 1 minute, right? Times. We want minutes up here. What's the next largest unit of time? Minutes to hours. So what do we know? How many minutes are in how many hours? 60 minutes are in 1 hour. Times. We want hours to be on the top, so it cancels out. Hours, and the next unit of time is days, right? We know there are 24 hours in 1 day. And finally, if we want to go to a year, we know 365 to a year. All right, we'll finish this up tomorrow, hopefully. Make sure you have done homework number 1.